Hello everyone, I'm Yash Sinha and my colleague Jitu are going to explain a video presentation on the topic KNN classifier algorithm, which is a machine learning algorithm. So now I will be giving the background of what actually is a KNN classifier algorithm or what is the purpose of using it. The KNN algorithm uses a majority voting mechanism. It collects data from a training dataset and uses this data later to make prediction for new record. For each new record, the k closest records of the training dataset are determined. Based on the value of the target attribute of the closest record, a prediction is made for the new record. The k nearest neighbor or the KNN method computes the Euclidean distance from each segment in the segmentation image to every training region that you define. The distance is measured in n-dimensional space where n is the number of attributes for that training region. So why actually we need a KNN algorithm? Suppose there are two categories, category A and category B. We have a new data point x1. So this data point will lie in which of the category? So to solve this type of problem, we need a KNN classifier algorithm. With the help of KNN, we can easily identify the category or class of a particular dataset. Consider the below diagram. It will give a proper explanation of the KNN classifier algorithm. This here is before KNN and this here is after KNN, and this is the simplified version of this KNN classifier algorithm, which is depicted by a programmatic representation. KNN, also called as K nearest neighbor, is a supervised machine learning algorithm that can be used for classification and regression problem. K nearest neighbor is one of the simplest algorithms to learn. K nearest neighbor is non-parametric, that is, it does not make any assumption for underlying data assumption. In more detail, how KNN works is as follows. Are the steps that we use for making the KNN classifier algorithm approach. First is we determine the value of k, that is the number of nodes. Calculate the distance of new data with the training data. For calculating the distance, here we have total three approaches. That is, we can calculate the Euclidean distance or the Manhattan distance or the Minkowski distance. Find the closest k neighbors from the data or find the nodes that are in the neighborhood of the chosen node. New data class prediction. Then we do the evaluation or we find the accuracy. Now here in this slide I will be giving the dataset information from where is it taken or what is the basis of the sample collected in the dataset. The dataset we have chosen is the iris dataset. The iris dataset was used in R. A. Fisher's classic 1936 paper, The Use of Multiple Measurement in Taxonomy Problems, and can also be found on the UCL Machine Learning repository. It includes three iris species with 50 samples each as well as some properties about each flower like the sepal and petal. One flower species is linearly separable from the other two, but the other two are not linearly separable from each other. The iris dataset contains four features: length and width of sepals and petals of 50 samples of three species of iris: Iris setosa, Iris virginica, and Iris versicolor. These measures were used to create a line and discriminant model to classify the species. Now here are the useful links which will be leading to you to the dataset from where we have taken the iris dataset. One here important note is that first we have imported the Jupyter notebook from the sklearn platform or the scikit-learn platform, which contains some simple algorithms to be solved using the machine learning algorithm. So for doing that we use it using pip install command in the either in the command window or in the Jupyter notebook itself after installing the Jupyter notebook. So the command for it are pip install scikit-learn or pip install sklearn, which is one and the same. Now here comes the important part of the video presentation, that is optimizer, or how we are going to improve the accuracy of our machine learning algorithm. KNN is so simple method that there is pretty much nothing to tune besides k, that is the number of nodes. KNN is so simple that it's an instance based non-parametric algorithm. That's what makes it so beautiful and works really well for certain specific example. Most of KNN research is not in KNN itself, but in the computation and hardware that goes into it. Some other optimizer tools are data preprocessing. Preprocessing the data can improve the performance of the KNN classifier. For example, scaling the data to have zero mean and unit variance can help ensure that features with larger magnitudes do not dominate the distance metric, that is, the Manhattan distance or Minkowski distance or the Euclidean distance. Feature selection. Choosing the most relevant features for the problem at hand can generally improve the performance of the classifier algorithm. Next is the distance metric. Choosing the right distance metric to measure the distance between data points can improve the performance of the KNN classifier. Popular metrics include Euclidean distance, Manhattan distance, Minkowski distance. The fourth option is the algorithm optimization. There are several algorithmic optimization that can be applied to the KNN classifier to improve its performance, such as using a KD tree or a ball tree for efficient nearest neighbor search. K-value selection, that is the most important optimizer tool we have for the KNN classifier algorithm. That is why it is said to be so easy algorithm. The choice of the K-value can have a significant impact on the performance of the KNN classifier. A small K-value may result in overfitting, while a large K-value may result in underfitting. The best K-value is problem dependent and can be determined throughout the validation. So now further going on for the video presentation, we have parameter tuning, that is how or what parameters we need to be tuned for getting the perfect accuracy of our machine learning algorithm. In machine learning, we use the term parameter to refer to something that can be learned by algorithm during training, and hyperparameter to refer to something that is passed to the algorithm to be solved. For example, the number of neighbors to inspect in a KNN model is a hyperparameter. A hyperparameter is a parameter of the model that is set before the start of learning process. Different machine learning models have different hyperparameter. You can find out more about the different hyperparameter of KNN here. We will use the exhaustive grid search technique for hyperparameter optimization. The most important hyperparameter for KNN is the number of neighbor, n underscore neighbor, test value between at least 1 and 21, perhaps just the odd number. It may also be interesting to test different distance metric for choosing the composition of the neighborhood. Now here is the result comparison of our machine learning algorithm. Sepal width versus sepal length. Setosa versus versicolor. Here is the diagrammatic representation of this. Green here represent category A, blue here represents category B. Any other new point in the n-graph dimensional data can be either in category A or either in category B. This can be found out using KNN classifier algorithm. Now earlier was for a sepal, now here is for petal. Length versus petal width. Setosa versus versicolor again. Now here comes what I actually learned from the project or the assignment which was given to us. From this assignment, I came to learn about the KNN classifier algorithm and how it can be optimized for accuracy by using the optimizer. Also, we learned how to use the Jupyter notebook for the purpose of machine learning and data science, and how to import various models, modules, and packages. We also learned how the dataset is imported within the Jupyter notebook and how is the part of any dataset viewed using .head, .describe, and .tail, etc. How to train an algorithm for various cases to get our outcome on basis of many cases. This is all what learnings I learned from this assignment. Now the outcome for the machine learning algorithm that we have chosen using the dataset we have chosen from the Kaggle or either the sklearn website, which we get as 96.967, which is our accuracy. So here is the code of Python in Jupyter Notebook on how to get the accuracy. Here we use the fitness value, that is more fit is preserved or lives, others die, that is survival of the fittest. The nodes which have the highest fitness value or the least Euclidean distance from the chosen or the new node in our either in our category A or category B, the fitness value which that is the distance which is the least will be chosen and the others will be rejected. So this is the basis of our fitness value. Now here I will be providing the link for the video presentation after completing this. Now here comes the end of our presentation. Thank you so much ma'am for giving us this opportunity. Thank you from my side and my colleague Jitu. Thank you.